Today we're going to talk about oxyacid nomenclature. So let's start with our EQ. It is, how do I write names and formulas for oxyacids? Okay, so let's start with the word oxyacids. If you think about it, we should know exactly what that is. Okay, we defined acids yesterday, something that starts with hydrogen. Oxy is the shortened version of oxygen. These are acids that contain oxygen. Okay, so oxyacids are acids that involve a polyatomic ion. Oxyacids. Okay? So you're going to need your pink chart for this because we're going to need to reference the pink chart for the polyatomic ions. Okay? Now again, oxyacids should always start with hydrogen. So let's start with how to write the formulas. When writing the formula, you start with H, always. Start with H. Then you're going to look at the ending. Now this is why this can get tricky, because the rule is different depending on what the ending is. If it ends in OUS, this is an ITE polyatomic. If it ends in IC, this is an ATE polyatomic. Okay? So once you figure out which polyatomic ion it is, you write the formula for the polyatomic. The charge of the polyatomic is the subscript, the little number at the bottom, for the hydrogen. Whoa, Miss Crane, calm down, woman. All right, let's grab that polyatomic ion's pink chart and let's have a look at some examples. Sorry for the glare on the picture. It's hard to do this well with laminate. So we'll just still steer clear of the ones that are not easy to see. All right, so let's say that we have the name sulfuric acid. Okay, well, since it's an acid, we're going to start with H, always starting with H. Then we're going to look at the ending. This is an ic ending, and ic means it's 8. So we change that ic to 8. So this is sulfate. Everybody see that? This is sulfate. Okay, so we're going to go to our polyatomic ions chart, and we're going to find sulfate. It's right there, and it's SO4. The charge on SO4, look up here at the top, SO4 has a 2- charge. We're going to take that 2, and that's going to be our subscript for the hydrogen. So this would be H2SO4. Let's do another one. So let's say we have perchloric acid. Okay, we know it's an acid, and acids start with H. Always going to start with the H. Then we look at the ending. It ends with ic, and remember, ic means 8. So perchlorate is the polyatomic we need to find. That is right here. It is ClO4. And if you look up at the top, this is in the -1 group. So the subscript for hydrogen would be 1, but we don't write 1s because we're lazy. So this would just be HCl4. Okay? Let's do one more, and then we'll talk about how to write the names. Okay, let's say we have phosphorus acid. Okay, it's an acid, and acids start with H. We always start with H. This time our ending is an us ending, and us comes from an ITE polyatomic. So we are looking for phosphites. Phosphite. So we're going to go to our polyatomic ions chart. Phosphite is this one here, PO3. And if you look at the top, this is in the 3- group. So you would put a little 3 on your hydrogen. So this would be H3PO3, phosphorus acid. Okay. Let's talk about writing the names. To name an oxyacid, you're going to look at the polyatomic. Find its name. Then you're going to change the ending. And again, there's more than one way to do this. If the polyatomic ends in ATE, you're going to change that to an ic acid. If the polyatomic ends in an ITE, you're going to change that to an us acid. And that's it. You're going to leave it alone after that. Okay, so let's do a couple of these. So let's say we had HBrO3. Okay, we're going to look at the polyatomic, and that's going to be everything after hydrogen. So BrO3, we're going to match that on the polyatomic ions. That is bromate. Okay, then we're going to change the ending. So we're going to get rid of the ATE, and ATE becomes ic acid. So this would be bromic acid. All right, let's do HClO2. HClO2. So again, let's look at just the polyatomic ion, ClO2. We find it on our chart. That is chlorite. Okay, and now we're going to change the ending. We're going to lose the ITE. And ITE becomes OUS acid. So this would be chlorous acid. And that's really it, guys. The biggest trick is keeping this straight with what we did yesterday. Okay? Remember that binary acids are not going to have a polyatomic, and they will start with the prefix hydro. So notice how none of these have hydro on it, because it's an acid. We know there's hydrogen. We don't have to say that. When we call it a hydro something acid, we're implying that it is binary. Oxyacids are not binary, so they don't have the prefix hydro.